All right, good people. Let's see. Number 4. Can it give us some more examples of how we can use the definite integral as an accumulation function? Let's see. We had the same scenario as number 3, but this time we're given a different set of data. The table of values that we're looking at represent W of t, the number of liters of water in the tank at a given time. So at time 0, there's 5,000 liters. That's different than over here, where at time 0, water was coming in at a rate of 3,000 liters per hour, right? So this is different, and so on and so forth. What does the integral from 0 to 8 of w prime t dt represent? So be careful. We're looking for the integral of this, but that's not what we're given. We're given the antiderivative or the original function of w. So what does this represent? It's going to represent the same thing, right? This is the total amount of water pumped in the first 8 hours. So what we get when we figure this out is going to be the total amount of water that was pumped in the first 8 hours. Not the total amount that's in the tank, but the total amount that was pumped in, because we're taking the integral of a rate of change. Now, what is that? Well, I'm not going to use a Riemann sum, because we only use a Riemann sum when the integrand, when what we're taking the integral of is the information that's given, but that's not what we're given, right? And so in this sense, we can use the first part of the fundamental theorem, which says, if I'm taking the integral of a function, then take the antiderivative of that, substitute the top, minus take the antiderivative, substitute the bottom, and subtract. And whatever we get there, that's the answer. So do we know the amount of water at time 8? We do. Do we know the amount of water at time 0? We do. And so the total amount of water that was pumped in the first 8 hours, which is what this integral represents, is 17,000 liters. Do you see how we can use it? It all depends on how you read the question, and more importantly, what you're given and what they're asking for, right? And you're able to get an answer fairly quickly, especially here with number 4. Okay. Should we try one more? Let's try one more, and then we'll pause. And then maybe in class, we can try some of these other wordier problems that look like they came straight out of a free response test. No, free response part of the calculus test. All right, let's do number 1 just to get it out of the way here. The rate of consumption of oil in the U.S. during the 1980s, measured in billions of barrels per year, is modeled by this function. So this is the rate. This is a rate of consumption of oil. This is what we're looking at. Where T is the number of years since January 1st, 1980. Find the total consumption of oil in the U.S. during the 1980s. Ooh. All right, well, let's see. The total consumption of oil. Well, this is the rate of consumption, right? So that means I can, and this is a rate. So then I'm going to take the integral of this rate. And again, I'm just going to use the name since they gave me the name. And then I'm going to say T is the number of years after January 1st, 1980. So I'm going to start at 0. And they want everything during the 1980s. So I'm going to end at 10. All right, 10 years later, that's the end of the 1980s. And so if I find this is going to give me the total consumption of oil, because we're taking the integral of a rate, the rate of consumption, which would give me the total amount of consumption. So let's use a calculator to figure this out. Let's see. Handy dandy calculator, help us out. So this is going to be math 9 from 0 to 10 of 27.08 e to the power of, and now I need to make a little fraction here, x over 25 dx. Oops, put it in the wrong spot. Dx. I think this is it. Press enter, and we get this. Oops, I let it go away. 332.965. Remember, three decimal places, it needs to be accurate up to three decimal places. So either truncate it or round it to three decimal places. Don't put two decimals, don't put one decimal, three decimal places. 332.965. 332.965. Now, what did we find? Well, this was the billions of barrels, not per day, because if it was per day, that'd be a rate. This is the total amount that was consumed by the US in the 1980s. And this is my answer. So I hope you kind of get the idea that whenever you're given a rate of change and you want to find something about the original quantity, the net change of the original quantity, the total change in the original quantity, it's all about taking an integral. And that's what we're going to practice in class the next time we see each other.